Great to have all of you here. I'm Achim Rettinger. I'm a full professor for computational linguistics at University of Trier. From my studies, I'm more a machine learning person. So I did my studies at the University of Koblenz on robotic soccer in the beginning. It's quite a while ago. And I also studied at the University of Georgia in Athens, USA. Also studied at the AI Institute at the University of Alberta in Edmonton, Canada. Then I switched for my PhD to the Technical University in Munich and did my PhD mostly on the combination of machine learning and symbolic AI, so description logics to be in particular. And then for the last almost 10 years, I spent at the Karlsruhe Institute of Technology, also one of the biggest technical universities in Germany, mostly working on knowledge representation and machine learning for knowledge representation. So nowadays called representation learning. And since 2 years ago, I became a full professor here at the University of Trier, where I'm heading the computational linguistics department. Although I'm not a linguist at all, I'm a computer scientist and machine learning expert. And that's, I guess, what I'm going to talk about today. Let me share the screen. So, okay, can everybody see my screen? Perfect. Okay, so great to have you here. I hope there's something new for all of you here. It will be a very high-level talk. So now, if you know already about language models, then it might not be too much novelty there for you. But I thought it's better to kind of have everyone on a good level and don't start with something that people can't understand if they don't have the background. Okay, so. So that's basically my my academic path that I just talked about. And today I wanted to talk about two things, basically. One thing is what's natural language processing in general, and what are language models and how good are they actually? Are they dangerous? Can they be abused? And as you can probably guess, one of the options to abuse a language model is for fake news generation. So I'm going to talk about this, first about detecting fake news, generating fake news, and finally also about detecting generated fake news. I'm not going to go into much detail. I'm basically talking about the most important seminal papers that were published in this area in the last couple of years. Okay, so first of all, what is natural language processing? In Germany, we always say like computational linguistics, but we mean natural language processing. And since most of you are from this area, I guess all of you also know about those logos here. I guess if you don't, raise your hand, but I would assume everybody knows what's behind those logos. So those are the well-known digital assistants, like Siri or Cortana or whatever from all of the big companies. They know they have this language assisted technologies, and they have made it to a large extent also to our living rooms. So this is, I guess, the most well-known application of natural language processing that has made it into like the mainstream and the center of a lot of people's living rooms and lives. So everybody knows about that, but I guess we use natural language processing constantly every day. So if you just take a Google search, there's a lot of natural language processing going on in the background. Every time you type something like a simple query, there is some natural language processing models going on. Also, the language models that I will be talking about to actually understand what is being typed into the search query, for example, in this case, disambiguating that it is about a name of a person, and this person, that it has certain characteristics and a certain job, and that it's shown on certain images and so on. So this is all natural language processing technology in particular, but more in general, some sort of AI technology that is going on there, and we are using this like multiple times every day. So natural language processing has made it, like I would say, in the mainstream of the technologized world, right? And what I'm mostly interested in my research is the combination of natural language processing and media. So where it is used in both mainstream social media, alternative media, and so on. And just to give you here a short idea about how it is nowadays used in mainstream media, specifically in newsrooms, right? It's basically used in all of the different steps of the news production cycle. So it's used for news gathering, for news production, for news distribution. And most of at least the bigger companies already use it to more or less larger extent. And there's also, at least I'm involved in a lot of projects and proposals that try to advance those systems and also deal with all the challenges that come from new media, social media, and so on. And challenges I will be talking about more today. Okay, so still to just give you the bigger picture of the terminology here, what is natural language processing in relation to AI and computer science? I think this is, I like to see it as some sort of a subset. So AI as some kind of umbrella term for systems that mimic human behavior or mimic cognitive capabilities of humans. And natural language processing can be seen as a sub-area of artificial intelligence, where I mostly like to see it as an application area of AI tools to natural language. So human language, spoken language, written language, and so on. Yeah. So to give you the very high level idea, I guess you as the younger generation, you know all of this already, the AI tools, how they are typically been used. So the more classic tools, how natural language processing was done, let's say 10, 20 years ago. So for artificial intelligence, that's not a long time. For any other scientific discipline, that's very short time span, but in the last 10 years, a lot has changed in this area. So the classical tools were mostly about analyzing text by using grammatical rules, right? Just using the words as symbols and applying grammatical rules on top of them to different extent, right? Up to really formal logics, and try to get a logical representation from the text to analyze it so that the computer can understand what's actually meant with a sentence. So this has fundamentally changed about 10 years ago, and the two things that came together that changed it, I guess you have heard the story quite often. The one thing is big data. So a lot of data became available primarily through the internet, right? There's so much text on the internet. You really have all sources there available. And the second one was some advances in machine learning, specifically in deep learning and artificial neural networks. And put those two together, we managed to kind of develop methods, mostly nowadays those language models and the transformer architecture that made it possible to analyze something like a grammatical structure of a sentence without handwritten rules. Right? It became possible to encode all this information that's inside a sentence and all the dependencies that are between the tokens that are in a sentence just by letting a system read a lot of text. And by a lot of text, I mean a lot more than a human can read in a lifetime. So multiple times more than a human can read in a lifetime. And but we could show that the grammatical rules that humans can come up with, or linguists did this for decades and centuries, they can be extracted by those kind of more statistical approaches already, right? So this was a revolution, you could say, in natural language processing. And the big progress was made in the area of language models. So basically, I put here, it was overrun by those large neural language models. Everything in natural language processing nowadays is, not everything, but 90% is related to language models at the moment. And all the other areas are, at the moment at least, not that active, but I guess at some point, as it always is in science, it will turn again. But language models is their thing. And to give you a basic idea how they work, or what's the principle that they are based on, I'd like to show you this short clip. It is about a game show, a pretty old game show. You probably all don't know. I don't have seen this at this time. It's probably, I guess, like something like 30 years old. It's a word guessing game where you have to describe a word to the next person, and the next person has to guess what the word is, and you are not, of course, not allowed to say the word itself. I guess let me play the clip, and I hope you can hear the sound. If not, then I have a transcription on the next slide and we can read it together. Okay, so could you hear this? The sound? No? Oh, yeah. Sorry. I'm not sure. I guess I would have needed to check some box. We can read it on the next slide. So the interesting part you need to pay attention to is if this is always some kind of logical description of what is a horse, right? And this is quite interesting to look at. So the first, so this is just about that it's about to start, and this is the first person describing a horse. And she says, a colt grows up to be a, and the second person asked, excuse me, I didn't understand what she was talking about. And then she rephrases and says, a pony grows up to be a, and then she immediately gets it, right? And this is quite interesting because if you look at it, a colt is a young horse. So this is actually the logically sound description. And a pony is a grown up small horse, right? So a pony cannot grow up to be a large horse. So this is logically incorrect, the description here, but this she gets, this she doesn't, right? So there you can already see that in this kind of word guessing games, it's not so much important if you make a logical, consistent description of the object. It's more important that you name some stuff that is kind of close to it, closely related to it. And if you continue to see the next persons, like cowboys ride these, right? It's just cowboys, people immediately associate a horse with a cowboy. Here, hoofs, right? So the legs of the horse, yeah, and they can get to the horse. And then here is basically just a description of what a young child likes to do, right? And this is also more like a association of different terms to this, because there's no mentioning of like get on this thing. It's not even that it's an animal or something, right? It's really, really far away from what it's actually described, and they still get it, right? So the interesting thing is, if you now think about if the word in question is being guessed correctly, if it's a logically consistent statement, obviously not. Most of the times it's not. Also, the structures used to describe the word are grammatically correct. This is almost never the case in spoken language. If you have ever dealt with analyzing spoken language, there is not really grammar in spoken language, to at least to some degree that you could apply rules to it. And then the B is, of course, the obvious thing, that you need to name words that are associated in your mind to this object that you want to describe. And this is often enough to describe it. Yeah, and so this is basically this distributional hypothesis with which all of those big changes in natural language processing went along. So the idea was to not represent words by symbols, but by distributions over the words they appear with. And this was in computer vision. This was also done in a similar way in knowledge graph embeddings and embedding of symbolic knowledge representation. This idea was also then later used, which is just don't represent the horse by a symbol that is about horse, but represented by hoof, pony, cowboy, and so on, and as a probability distribution over those words. And this kind of made a big change, because now you don't have to match the sequence of strings for horse exactly with horse to kind of find out what it is about. So you don't need to have a vocabulary of horse, and you don't need to match it exactly. You can match it in a different way over those distributions, and they are called embeddings. Something you probably have heard if you have dealt with machine learning in any sense. Okay, so the basic idea is how you kind of can predict this, for example, is to say, okay, I want to represent the word go, and I can do this by the words that are before and after this word, and you kind of learn a probabilistic model that can just say a representation that captures what you predict of representation that predicts best what are common words mentioned before and after, or in a sentence together with this word are this and that. Okay, and this way, yeah, natural language processing was kind of revolutionized, and there was a language model in this sense is then a model that can, given a certain word, predict what are words that come next or before, right? That can generate words. This is a language model, a statistical model that can generate sentences or analyze sentences by kind of calculating probabilities, how likely the sentence is, what are missing words in the sentence, if it's half a sentence, what's the next sentence, and so on. So this is kind of the revolution that took place, and the most successful architecture was the transformer architecture. So it's a deep learning architecture. I will not go into the details how this works, but at least give you some idea how it changed natural language processing. So I guess you all have heard about AI techniques that can achieve superhuman performance on some tasks, right? And there's a long history of AI systems that beat humans, like on Go or chess or those kinds of things, or Jeopardy, right? This is all examples of AI systems that could beat humans. So are those language models really, how good are they? Do they really understand language as a human does, or how well do they do against humans? And there's a big open question behind all of this. Actually, how do you measure language skills? It's not that easy, right? It's much harder than measuring the performance in a game, because there at the end someone wins and someone loses. It's very simple. In measuring language skills is much harder. Okay, so one way of doing this is you need to have some sort of a benchmark, right? And how this works is, for example, you start with a question. You have a natural language processing system, for example, a language model, a transformer-based language model, and it generates an answer to this question. At the same time, you give this question to a human expert. It answers this question, the human expert, and then you have some similarity measure who assesses if the machine-generated answer is the same or as good as the human expert's answer. And then you can, in the simplest case, calculate something like the percentage of correct answers, right? So this is how a typical benchmark of an NLP system looks like. And besides question answering, there are different tasks. For example, this reading comprehension tasks that are typically at least thought to be very hard for computers, but pretty easy for non-expert humans, right? And there's a very famous benchmark task that it's 9 reading comprehension tasks combined in one benchmark, and it's called the CLUE benchmark. And some examples of what they do is, for example, they show 2 sentences. The first sentence showing a statement, and the second sentence showing something that might be related to the statement or not. And you can then, as a human, easily assess if the second sentence is consistent with the first sentence, right? For a human, that's pretty easy. For the computer, it wasn't that easy, right? At least before the transformers came along. Or here's an example for this co-reference challenges, where you have in a sentence, you have references to different entities and sentences that are not explicitly mentioned, right? Like friend. And you ask the computer and the expert, does he refer to friend or John, right? Something like this. And you have to classify it this way or that way. And you could, at least if you quickly think about it, you're not into natural language processing, you would say, man, this must be hard for a computer to figure out, right? It doesn't seem to be easy. And they have like 9 different challenges like this, like also question answering and so on. Okay, so this CLUE benchmark was released in 2018. And at that time, this was before the transformer architecture became popular. The LSTM, it's also like a recurrent neural network architecture, was mostly used. And the authors of this benchmark, they also applied the state-of-the-art methods on those tasks and came up with a number, right? They said, okay, state-of-the-art NLP methods can do something like achieve a score of 70. Then in October 2018, so only a couple months later, with the transformer architecture, they got a bump of 10 points. And if you are in this area of machine learning, you know that a bump or increase of 10 points is huge, right? Normally you need something like a decade to get in some benchmark tasks increase the performance by 10 points. Yeah, so then they thought, okay, 80, it's a huge increase, but we don't even know how good a human non-expert is on those tasks. We don't know. So they showed it to like humans that are non-experts in this task, and they came up with a score of 87. I thought, okay, still humans are better than computers, so there's no superhuman performance here. But actually, again, only a couple of months later, improved transformer architecture from Facebook AI was released, and they, for the first time, beat the humans in those tasks. So yeah, so that means for the first time, the transformer beat the human. And then a big discussion started. Is the computer actually understanding what he's doing there, right? Is he understanding language? Is this possible? So they thought about it, and then a lot of papers were written about this, and they thought, man, this apparently the computer doesn't really understand what's going on. But we just need to find better tasks, right? We have to come up with new tasks that are harder for the computer, but still easy for the human. So they came up with the superglue benchmark in 2019, and they applied the state-of-the-art transformer method. At this point, it got around 70% or the score of 70. And they also did a human baseline, right, with non-human experts, and it almost achieved 90% on those tasks. So they said, good, humanity is saved. We are still 20 points better, almost 20 points better than the best language model. But then again, only a couple of months later, Google released a huge language model, and they basically had the same performance as the human baseline. And then, I don't know, a year later or something like this, yeah. So they kept on pushing this bigger language model, more training data, slightly different tuning of those models. At some point they improved it. I actually haven't checked what's the best score at the moment. They probably improved it even more. So it is kind of the lesson learned there is, or the question is, has the computer now understood what is said in those languages, in those sentences, in this reading comprehension task? And I mean, this is an interesting debate that we can have later. But I would say, no, not really. I mean, the systems didn't become much smarter than in the beginning. Even the first system itself was not fundamentally different to the best systems now, right? There's the architecture, all of the training methods, they have slightly tuned it, but it's not fundamentally different what the systems can do. But you can see what you can achieve with very large language models, so huge neural networks and a lot of training data. So, and it's still an open question how you can test a natural language processing system and compare it with a human performance, right? Because the biggest limitations of this automated benchmarking task is that you always need to have some measurable outcome, right? You always have to say it's a classification problem, it's a yes/no problem, or whatever, right? You need to generate something that you then automatically can assess and score, right? And this is a big limitation. So again, transformers beats human. Yeah, so coming to the second part of my talk, are those language models actually dangerous? Can they be abused? And yes, they can. I guess you all heard about some examples of the ones that I will be showing now. So they can, for example, be used to just generate text. And there have been examples where actually books have been written with language models and sold on Amazon, and people have made money with it. I don't know the book. I would assume it's not really interesting to read, but still people have paid money for it. So it is kind of crazy. And there's a lot of examples where people have used those language models to generate text, for example, for their own blogs. So they just made up a blog, and they wrote blog posts using a language model. and they gained a lot of followers, and by just generating, automatically generating those blog posts. So yes, obviously, at least you can have some malicious intent in the sense of, yeah, commercial interest behind it, right? So those are not really, I would say that it was not intentionally malicious in the sense that you want to misinform people, yeah, or yeah, but at least it was not what people expected. And then there was a big controversy about one of the best language generation models at that time in 2019, the GPT-2 model from OpenAI, which was not released because they said it's too dangerous. People can abuse this model. So we don't make it public. We don't make it openly available because we are too afraid that someone will use it for generating misleading news article, impersonating others online, automated production of fake news, and so on. So, and there was later also papers that showed that it is actually possible to really generate text that can be seen as propaganda or can be used for propaganda or extreme radical content and so on. So there is the potential to not only make money with it, but really also propagate information that is really fake or maliciously, the intention is maliciously like wrong. Okay, but there's also, of course, hundreds, thousands, whatever examples of where you can do good with those language models, right? Really understand more or better understanding what people write. So nowadays it's most used in most Google queries to disambiguate what you're really looking for, right? There's a lot of apps that use those language models in the background. And there's also good ways to make money with, right? There's a lot of new applications are possible using those language models. And you always can, of course, use it to also analyze the text, right? And this is what I want to show now. With one example, namely fake news. And the first, of course, is just, I guess you don't have, I don't have to tell you about fake news. The first thing is, of course, fake news detection, right? If you have disinformation that's written by humans, you might want to check it in some way, right? You want to assess if this is false or if the intent is malicious or something like this. And I guess, yeah, we had in the last years, we had enough examples, at least in the US and elsewhere, of really disinformation being propagated. One of the things that's not necessarily related to natural language processing is also that it has become so good that here those deepfakes, they are referred to computer vision, so that you can actually, in a video conferencing call, you can mimic another person, right? So you sound like a person, you look like a person, and like another person. And so there's a big potential of kind of really doing malicious stuff with those technologies. So it has become a big challenge for social media platforms, for content moderation tasks in general, but also a big business. So a lot of businesses are actually working on this and offering services to check content. And maybe the most interesting part of this is that on most of those platforms, something like misinformation or something like so harmful content or hate speech is flagged by some sort of NLP or AI algorithm. So I think something like, I don't have the slide here. It's something like 95% is not ever seen or judged by a human. It's just classified by presumably machine learning approach, so something like a language model, and classified, and then it might be checked again by a content moderator, but I doubt that this is possible just looking at kind of the amount of information that's produced on those platforms and distributed on those platforms. So only the ones that are probably reported by users or where the AI is not very confident about if it's fake or not, will be checked by a human moderator. Okay, just to give you some more terminology here. So the one is kind of that is mostly moderated is for hate speech, can be offensive language, but can also be abusive content. And then there is this fake news category, and there's a lot of different subcategories, which is if the information is intentionally false, then you call it disinformation. If it's unintentionally false, you call it misinformation. Clickbait, satire, biased reporting, and so on. So that's really hard even to classify, because you can write a information piece and not saying any, which doesn't contain any falsehood, but by just selectively reporting information, you can produce kind of a biased news article, and misleading and also malicious news article. So it's really a really tough challenge to kind of detect this. Yeah, so just giving you a short idea what NLP researchers are trying to do to classify this automatically. There's a nice overview paper where they classify this in 4 different, let's say, indicators, how they can analyze if something is fake or not. So you could go really deep into the meaning of a sentence. Is the statement or the claim that is made in a news article, is it actually true? So you can check it with background knowledge and so on. If this is actually true, if the statements are consistent, if on the web there are a lot of counter statements and so on, you can check it this way, but you can also check it by style. Sometimes you can detect fake news just by how it is presented, that it's more sloppy or not as nicely presented. Then there's also often propagation-based methods that say, okay, if I know we have certain accounts that like to propagate fake news, and there is some news that comes from this account, maybe it's also fake, right? There's a higher probability it's fake, or certain users share this information that makes it more likely to be fake. And finally, it can also be based on the source. So the one is like the propagation pattern, how it propagates. So often you can show that in kind of circles, alternative media circles, the information is quicker shared, but in a more condensed network. But it can also go by kind of the trustworthiness of the source the information comes from. So there are different ways how to do this. You can integrate it, you can analyze only the text, the layout, the image, whatever. It's all different sources of features to classify if something is fake or not. And then you throw this in a big neural network. Typically, if you choose a machine learning approach, you generate those embeddings that I talked about of the text and maybe the image and what else you want to analyze, the background knowledge, and then you classify in the simplest case if it's fake or not, right? And this is one thing, and what is maybe even more interesting is that if you don't have so at least let's put it this way, if you have a human who generates fake news, this still is a lot of effort. So you need to have kind of some resources behind it. That's typically only possible by some bigger governments to really put this resource together to have big fake news campaigns that are driven by humans, right? So, but there's another danger here with this language models, and this is by generating fake news. Right? So with the language model, you cannot only analyze text, you can also generate text. And there's this big paper proposing a method called Grover, and they just proposed use the language model to generate fake news. And the interesting thing is that you could specify certain context parts. You could say it should be written in a certain style, like for example in the style of Wired.com, should be associated to a certain date, it should have a certain headline, and then this model could generate the target text. Right, and once the text was generated, you could do another classifier and say, okay, now let's predict the authors. What are the most likely authors that would write an article in this style with this headline for this domain? And that could generate the authors and so on. So you could later also improve on something like the headline to make it more consistent by really predicting it using the language model. And at least in this paper, they showed that, so the last blocks here are the interesting ones, that the propaganda, so the fake news, the machine generated propaganda was rated as more trustworthy than the human one. The one generated by the humans. And you can use those systems, and there's also examples in the paper if you don't want to run the system yourself. They are really convincing. At least if you write something like a one-pager fake news, it's really hard to say if this is completely made up or if it's true, right? It's typically not something, or obviously not something that links to a real-world event, so you don't know about it and you just read something, and it's really hard to judge. And typically the machine generated text is also more better written. So it is, since it reads a lot of text, it typically doesn't have any errors, no grammatical errors. It's very clean text and nice to read text. Okay, so the final question, or the final thing I would like to talk about is, okay, so now if we can generate fake news with a quality that's hard to classify by a human, to detect by a human, can you use a machine learning algorithm to detect if a generated news is fake news, which pretty much automatically a generated news is fake in the sense it doesn't really refer to any real world information or event. Okay, and this is also covered in this paper. So you basically have kind of two models. The one is the generator and the other one is the discriminator. And what they show in this paper, that it's kind of a race, right? If you improve your generator, you have to improve your discriminator. And if your generator is a larger model that was trained on more data, it is hard for the discriminator to classify this. So just a few numbers, but the basic message here is that the larger the generator, the worse the discriminator, and the better, larger or more training the discriminator has, the better it is in detecting neural fake news. Okay, so this is kind of ending then up in some situation that you have with computer viruses, right? They kind of you can always improve the generating model. The fake news gets better, and then you have to, the discriminator has to be improved to also detect those types of fake news. So it's kind of infinite race that you're entering here with this fake news generators. Okay, so I guess that's it from my side. I hope it was not too boring for most of you, and I have some further consideration or topics that we could discuss about. So first of all, I would like to hear if you have some kind of own thoughts about it. Is this really dangerous? Is this a problem, or does it have an impact? Does it have a negative impact on anything? What would you say would be the best countermeasures? Or so if you assume that something should be done about it, what would be best to tackle this? And of course, then maybe also a bit more philosophical questions about who's actually the main driver, developer behind those language models, who's using this, who's putting all the money into it, and can those systems also be made in a way, programmed in a way, so that they are unbiased, that they generate fair content, don't do harmful things, abide to the law, right? There's also so many good examples about chatbots that just went crazy and were generating content that was not allowed on the platform and so on. So is this possible? Is it possible at all to kind of program something like ethical decisions? So there's really a huge area that connects to all of those things. And I think no one has the final answer here. Okay, thank you.
I have a quick question.
Sure.
So obviously, sorry, there's a fly in here. The fake news generation thing is alarming, especially the fact that like it's like just as good as like humans and it's hard to detect. So this is like a very basic question, but are they, let me rephrase. When I look for news, I look at like my sources where I typically get my news and like have my subscriptions to, you know? And so are these fake news generated by like NLP, are they on reputable sites or are they just kind of on like fake news platforms?
Yeah, no, so you should have, you should be quite certain that on a reputable source that they check what their sources are. But I mean, there are examples where they don't check their sources, and often on also like mainstream reputable media outlets, they only kind of report on top of something that they got from another source. And it already happened that some of this information was fake news, be it automatically generated or human generated, right? So even there, they typically cannot follow if it's a really long kind of history where this information comes from. They cannot really make sure that it came from someone who is trustworthy, or it's too much work because they are often under a lot of pressure to kind of publish very quickly, so they cannot check everything. And there's of course a huge difference between news outlets. So I know news outlets that say we only do this kind of slow news, where they say we only report stuff that we have verified to the core, and it takes a month until we write an article about a certain thing. But of course, then you have those systems that you've seen it in the beginning that basically republish content almost automatically. So there's just an AI running there, summarizing the content, and maybe there's one person sitting there and clicking release it, publish it or not, right? That's all there is. And this person, if there's not an obvious flaw in this article, he has no chance to check if this is really a good source or not. So yes, I think there is not a big, but some danger that even on a reputable source, you will get this kind of information. Yeah. But on the other hand, this is also, in my opinion, the big chance for this traditional mainstream publishers to really basically go back to their roots, do really good reporting, check the sources so that you can trust them. Because the more information, let's say on social media or alternative media are not trustworthy anymore, the more the people might go to the traditional sources. But this is an open question. I don't know.
That's
Any
really
more
interesting.
questions
Thank
of
you.
this time? Yeah.
I have a question. So, great presentation, by the way. Earlier, you showed a flowchart for Facebook as to how they moderate fake news on their website. So at one point, it's either a user reports content as misinformation, or they have AI flagging content. So I was wondering, currently, most of the fake news, I'm guessing on these websites, is more so like created and spread by humans. But as fake news generation by AI develops and I guess gets more advanced, how do you think like the workflow for like different platforms in detecting fake news will change as like more of the fake news is created by machines?
Yeah. Yeah. So I think so how I think for the near future it will not change that much, because it is exactly this race, right? You have this automatically generated content, and the platforms are always getting better and better in classifying the automatically generated fake news as fake news, right? But then the generator is getting better and so on. So it will stay like this. It will be a business, right? There will be companies focusing on content moderation, and I guess the companies that are better in automatically sorting out fake news have an advantage, because it is mostly about like sheer quantity of news that are generated on those platforms. If on the long term something will change, I'm not sure. I guess then it might be less technology driven, but more driven by regulations, something like this, or governmental intervention, this kind of stuff. Coming more from this direction. Maybe users will change their behavior. Maybe they will go back to more slow news sources that do manual checking of content at some point. This could be different, but from the technical point of view, I'm not sure if there will be a breakthrough in either direction, that you could say the the fake news generation will be so good it cannot be detected by anyone, or the other way around, that the detectors will be so good that no fake news will make it on the platform. I think this will always be a balance. Good question. So maybe this is actually a question to you. Do you think the rules and regulations should be changed? Because let me ask it this way. So at the moment, most fake news obviously is spread via social media or instant messengers and so on. And they, to a large extent, have their own regulations. Like they have their community guidelines that specify what's allowed, what's not allowed on a platform. And this is nothing that was decided based on a democratic process, right? It's something that somehow inside this company was figured out. Of course, it needs to be abiding to the law, what they publish. But that's basically it. Then they can do whatever they want. So my question to you would be, do you think it should be, it has to change, that those kind of also community guidelines on social platforms need to be decided not only by the companies, because they have a big influence on the information that is shown to the people? Should it be a democratic process? Does it have to be regulated in any sense by government? Shouldn't it be regulated? This is all very interesting questions that I also can't answer.
Yeah, I know Facebook has had a lot of issues with the government in regards to removing like their human fact checkers. And then they've had some issues with like misinformation being propagated on their site. So I think that it would definitely be a good idea as more fake news is being generated by AI to have more government regulation to ensure that there's like I guess more resources from Facebook to make sure that fake news is being handled and being suppressed as much as possible.
Mm. Yeah. Yeah, I mean, yeah. So I guess this will be happening because there is a real interest by governments to kind of at least don't allow fake news that undermine the democratic processes, like voting processes. But I think it also goes in the other direction that a lot of community guidelines actually don't allow information or filter information that might be should be allowed because of some reasons. Like, for example, I think TikTok, I heard a couple of days ago, they filter something like by like challenged people who, I don't know, look not as nice as or as normal as they should because they had some kind of defect. They only have one eye and a glass eye or something like this. This is blocked on the platform, right? Because they have this guidelines where you say they don't want to have something on the platform that looks abnormal, right? And this is something where you where the platform maybe overshoots, right? You don't it not all people have the same access to the platform just for some reasons um, that they cannot really control, right? They were born like this or whatever, right? And they have no malicious intent at all. And at least they are maybe not blocked from the platform, but the algorithms are not ranking them as high as the good looking people who, yeah, look like, yeah, models or whatever. They are always ranked higher. And this is maybe also something that in a more democratic process would be handled differently.
So I have a quick question. So with NLP and all that, we're talking about fake news and stuff like that. I think, like personally, that this is just going to be another way of like cybersecurity, where I mean, back then we didn't have to worry about computer viruses. It was until computers were invented and were personal, and there was a mean for you to go and attack someone. And in this case, we're now talking about data poisoning, data manipulation, and I mean, I can create a website and make it say, let's say Facebook or New York Times or the Washington Post. I can do that. It would be a different URL and just have my AI doing it and just keep going and trying like Google, manipulating with the search engine optimization. So, and the fact that I can do it, I mean, we see it now with a bunch of scamming websites. Like people can just freely do whatever they want, like with phishing. It looks like Facebook, different link. I mean, we were talking about more government like influence when it comes to this type of stuff, but I mean, all of these things move so fast, and of course, this can be the United States government, but someone can have some sort of access to, let's say, a Chinese IP, and they can create their own stuff there, or let's say, I don't know, Russian, Indian, whatever. It can be another part of the world where they're not regulated that much. So ultimately, it has to be Google or Amazon or Facebook or any of these. But even then, it's like, how do you really think that these technologies will work? It's just like how you mentioned before with viruses, antiviruses. I mean, it's always a battle between the two, good and bad. Do you think eventually it will calm down, or do you think it's just the start? Since NLP is barely becoming really good, deep fakes are becoming really good, all of these things are just going to add up to becoming pretty dangerous in the future. Do you think they're just going to start appearing more often, much more convincing. And if that's true, I mean, what besides using NLP detection, right? Because ultimately antiviruses fail at some point. How could we, I don't know, protect against it? I mean, we could do the due diligence of looking, right? Like, okay, is this real? But then again, we can also do the due diligence. Is this URL real? Is the English make sense? Like when it comes to scams, there's a lot of things, but with human error, that's always a possibility.
Yeah.
So what do you think?
It's a great question. I mean, this is exactly how I would envision it to happen, right? It will be a long battle, like with the spam detection, and there are several ways how this could change, or at least at some point be leveled out. And another option would, of course, be if the population, right, like the users, the consumers of news, if they are more informed and more aware of what's going on. Because if I tell this to my parents, they have no idea, right? If I show them a generated news article, they have no idea that a computer is capable of doing this, right? And so it will be another thing that people need to be aware of. They might then change their behavior. They might go to more trusted sources. There might be better, whatever, really like security protocols that you're not redirected to the wrong page and whatever, right? You're just receiving your news through some kind of secured apps, or I don't know what's coming there next, but it has to be a lot of different kind of improvements to make this work. And I think there's not the one easy solution. It needs to be some sort of regulation. It needs to be some more democratic processes. It needs to be, the technology has to be improved. You need to educate people better to know what they have to look for. And as we have seen with the spam detection, it takes a long time. I mean, there's still so many people who click on links in emails where they just shouldn't click on, or right, and that are quite obviously spam, right? They still do it. It's really, really a long battle, I think, ahead. So I think I'm sorry, I have to go to the next meeting. Sorry about that. I should have kind of expected more time for this, but I hope it was still interesting for you all. Great questions.
Thank you so much for your time. This was so fascinating. I really enjoyed it, and I think all the fellows did too. Totally understand on having to go to your next meeting. So thank you so much for your time.
Yeah, it was great having me. Thanks a lot. Bye-bye.